Hi everyone. So last time we starting for section 6.2 trigonometric upright triangles, and we talk about the triangle and the triangle ratios as showing in the photo. So this is the opposite for the angle theta, and we have, like, first of all we have right triangle such that this theta is theta, this angle is theta. The opposite of theta is this side, and the adjacent for this theta is this side, and the hypotenuse this side. First things, we define the sine theta is the opposite over hypotenuse, and the cosine theta is the adjacent over the hypotenuse, and the tan is the opposite over the adjacent. And again, the cosecant of theta is the same as 1 over sine. So this exactly like 1 over here. This is equal, oh sorry. This is equal 1 over sine theta. So 1 over sine theta is cosecant, is the reciprocal for the sine theta. And also secant theta is the same as 1 over cosine theta. And the cosine theta is the same as 1 over tan theta. Okay, so this is 1 over cosine theta, and this is 1 over tan theta. It's the same as the inverse for the tan theta is the adjacent over the opposite. Okay, and also we go over this table. Any questions so far for this lecture? Sine theta, cosine theta, tan theta, cosecant and secant and cotan. All these are called trigonometric ratios. This is the first things we finished it last time. Second things, we talk about this table. Here, this called special triangles, such that the 0 and 30 and 45, 60 and 90, such that we converted the 0 to the radian is 0, 30 to the radian is pi over 6, 45 to the radian, if we want to convert it, it's pi over 4, 60 is the same as pi over 3, and 90 degree is the same as pi over 2 radians. And again, what's the sign for the 0 is 0, the cosine of 0 is 1, the tan of 0 is sine over cosine, so it's 0, because 0 over 1 is 0. Cosecant, it's 1 over sine, but the sine is 0, so 1 over 0 is undefined. Secant of theta is 1 over cosine, so it's the reciprocal for 1 is 1 over 1. Cotan of theta, the same thing, 1 over 0, so undefined. So there is no value for cosecant of 0 and cotan of 0. For the angle theory, if we convert it to the radian, it's pi over 6. The sine of pi over 6 is 1/2. And the cosine of pi over 6 is square root of 3 over 2. The tan is, it's the sine over cosine, so it's equal square root of 3 over 3, or it's equal 1 over square root of 3. So here it's the same as, so here this, it is 1 over square root of 3. Here we're just rationalizing the denominator by section 1.3. That's why we get square root of 3 over 3. Like we multiply both of the denominator and numerator by square root of 3, by square root of 3. So we get square root of 3 over square root of 3 times square root of 3 is 3. That's why this equals the same things. This value actually is like 1. We multiply the ratio by 1. So we multiply anything by 1, it's the same thing. So 1 over square root of 3, the same things like square root of 3 over 3. Now, for cosine, cosecant, it's like 1 over sine. So we inverse this this fraction, so we get 2. And the secant of theta is the same things for 1 over this fraction. So it gives me like in different way, it's like the same as here. Hold on. So the same things as 1 over cosine. So they give me 2 over the square root of 3. Or the same idea by using here, we're rationalizing the denominator. So we multiply both sides by square root of 3, we get the same things here. Same things here, the cotangent is 1 over tan, and it's the same things here, the square, it's 1 over square root of 3. So we inverse this fraction, we get square root of 3. For the angle 45, it is, again, here is difference. It's 1 over square root of 2, or the same things here. This one is like is exactly 1 over the square root of 2. And here is the same things, 1 over the square root of 2. Here is 1. Here is the reciprocal for sine. Same things here for the cosine, and the same things for the tan here. And the same things for the 60 and for the 90. For the 90, the sine is 1, cosine is 0, but here we're undefined because the tan is sine over cosine, so the cosine is 0, so undefined. For the cosecants, it's 1 over sine, so is 1. For the secant is 1 over cosine, so 1 over the 0, so undefined. Again, here the cotan is cosine over sine, so it's 0 over 1, so 0. Look, the tan does not have a value, but the cotan, they have a value, such that the cotan of theta is 1 over 10, but the tan does not have value, so we're using the cosine over the sine. 0 over 1, so it's 0. Okay. Any questions so far for the table? Is it clear for all? Okay. Now let's go to application of trigonometric of right triangle. So we left 2 things from last time. First things is application. Before we starting for the application, okay. The final exam, I forgot to talk about the final exam. The final exam, I sent it yesterday, final exam. I sent yesterday by the email. It will be on 21st, May 21st. Let me check again my calendar. Yes, it's May 21st, 21, 2020, from 3:30 p.m. to 5:45 p.m. This is the final exam date. Okay. So here now, let's go to the exam will be covered for all the section in the book. So the exam for everything for all sections. I don't know exactly how many questions because I did not write the final exam. It's from the math department. But in general, it will be like 10 questions and it has a part. Like first question has some parts, yeah, like that. Will we be able to review our old homework? What do you mean, Asya? Review the old homeworks. I don't know. It will be in the Blackboard. I think they will send you a like PDF file for the exam, and you will start like writing and doing the in like white paper, blank paper, and they will submit it. I will let you know, like during next week. I don't know exactly how, but it will be the date for the exam. I like okay. I get email from the math department. It will be May 21st, from 3 o'clock, 3:30 to 5:45. This is the date for the exam. For more information, I will let you know during next week. So last things we left it from 6.2, the example application. So first example, suppose I have a right angle, look like that, right triangle, and here is A, B, C. The hypotenuse for the angle theory is 12, and this is A, this is B. The question is, find the value for A and B. Find the value for A and B. So how we start thinking about this question? So again, they give me this angle, the value for this angle, it is 30, and they give me the hypotenuse is 12. How we can find the length for B and the length for A by using trigonometric ratios function. So we know what's the value for the sine, and we know the cosine. So by using the sine function, sine of theta, sine of the angle theory, what is it? Is it the opposite over what? The hypotenuse. The opposite over the hypotenuse. So this is equal. What is the opposite for the angle theory? This is the angle theory. The opposite is A. So they give me A over 12. So the sine of theta, I know the value for the sine of theta from the table. Go back to the table, you get the sine of theta. What is sine of theta? What is sine of theta? It is half, yes. This is equal A over 12. Now, by multiplication, by cross multiplication, what we get? 2A equal 12. Dividing by 2 for both sides, I get the value for A is 6. So this is the first application. So now A is equal 6 by using the trigonometric ratios. The same things for b. How we can find the value for b? How we can find the value for b? Which function we can use to find b? So we need actually the adjacent over the hypotenuse. Yeah, okay. Because Amber, she asked question, I did not catch where did you get the 1/2 from? From the table. Go back to the table. The table I give it right now. The angle 0, 30, 45, 60, and 90. And the value for the sine, for the 0, cosine, tan, cosecant, secant, and cotan. Is it clear? Yes, but you have to memorize all the table. Yes, so you have to use the table to find the problem like that, but you have to memorize the table, okay? Now again, how we can find the value for b? By using the cosine for this angle. Why? Because the cosine is adjacent over the hypotenuse. So what's the cosine for the angle theory? It is b over 12. And again, we use the table to find the cosine of theory. What is cosine of theory by using the table? What's the cosine for the theory? It is square root of 3 over 2. Yes. This equal b over 12. And again, cross multiplication. What we have 2b equal 12 times the square root of 3. We divide both of them by 2. We get the value for b. This is equal 6 square root of 3. Is it clear? So this is the first example for the application. We have another example. Second example is that, suppose I have a tree, look like that, and we have a sun here. And this sun make a shadow for the tree like that. And this is the ground. And it make here as angle, the angle is 45. So again, the sun make a shadow for the tree. And also the length from here to here is given. It's 532 feet. The question is, what is the length for this tree? Question is, what is the length for this tree? So actually, we get a triangle with right angle. Look here. This is like right angle here. This is the right angle. So it is easy now to find the length for the tree. How we can find the length for a tree? Which function can we use? Which function of triangle we can use to find the length of the tree? The sine or cosine or tan, or which one of them? So we already have the adjacents and we have the angle. So the best things we can use here is the function tan of this angle, the 45. Why the tan? Because we don't have the opposite side. We don't have the length for the opposite for the angle 45, but we have the adjacent for the angle 45. And we know the tan is equal the opposite over adjacent. So the opposite, it's unknown. It doesn't have a value. It's the length of the tree. This is the length of the tree. Okay, over the adjacent of the value for the angle is given. Is it 532? And the tan for the angle 45, it is given from the table. Just go back to the table. What's the value for, what's the tan for 45? It is 1, exactly. So now it is easy to find the length of the tree. We do a cross multiplication. Here actually is over 1. So the length equal 1 times 532 feet. So this is equal 532 feet. This is the length of the tree. Okay, any questions so far? So the height from the ground, this point to here, the top of the tree, is 532 feet. This is the second application for using trigonometric functions. Anyone has a question? So now let's go to the new section. It is 6.3. This section is a little bit heavy, but I hope to be easy. Like after doing some examples and doing the web assignment questions. This one is called talk about the trigonometric function of angles. Yes, I will talk about the asymptote in the end of the class. Thank you, Taylor. So in the section 6.2, we use the acute angles. And 6.1 also, 6.2 only, we use the acute angles for the triangle. But now in this section, we'll talk about any angles for triangles. So for example, first things for this section, it is a trigonometric function of angles. So suppose I have, for example, a triangle look like that. this angle, this here is O, Q, and B, such that the angle, this angle is theta. Here's the opposite. Here's the adjacent. And here's the hypotenuse. So first things, we can transfer this angle as in the standard form by putting the graph of this triangle in the standard position in the XY plane. That means we're moving this side to the positive x-axis and moving this side to here, and the hypotenuse, this side, move it like that. So actually we move the triangle to the XY plane. This is the first step. So now the adjacent will be the x value, such that before we talk about the x value, so suppose that this is the O point, this is the Q point, and this is the B point. B has x and y coordinates. Okay, so that's mean the adjacent now will be the x value. The x value means the length from this point to this point. It has the x value. And the opposite, it is the length from this point to this point. This is the y value. This is y. Why it's y? Because actually it has a value here. This is the y. Okay? And the red one, by using the Pythagorean theorem, it's called R, or the hypotenuse, such that R is equal to the square root of x squared plus y squared. Okay, so R equal the x squared plus y squared. So by using this method, we can find the function of trigonometric. That means the sine of theta, because the theta now it's this theta. So the sine of theta is y over r from the graph. It is y, it's the opposite, over r, the hypotenuse. And the cosine of theta is x over r again. This is x over r. And the tan of theta, it is y over x. It's the opposite over adjacent. And the cosecant of theta is 1 over sine r over y. And the secant of theta is r over x. And the cotan of theta is x over y. So by transforming the graph of the triangle to the standard position, we can find any sine and cosine and tan, any triangle function for any angle. So if my angle is not acute, we can do it by this idea. We send it to the XY plane, then we can find the sine, cosine, tan, and cosecant, secant, and cotan. This is the first things we have to know about the angle. But now we will use a different way to find the trigonometric function for any angle, not just by using this position. So first things we have to know, what is the sign of the function. No, the acute angle, it's an angle between 0 and 90 degrees. From 0 to 90. This is called acute angle. Any questions so far for these things before we move to second things? So we already placed the triangle in the standard position. Instead of talking about agents and opposite and hypotenuse, we use X and Y and R. The same things for any triangle and for any angle. The same things, for example, if I have angle look like that. If I have to, for example, angle look like that, is not for that. I mean like something like that. This point is A, O, B. We can place it in the standard position by that. From O to A, be the x-axis. From O to B, look like that. And from A to B, we look like that. So the angle like that. So for solving this angle, the green one, we make here a triangle with right angle, and we will use these things, this triangle, such that here this is the value for X, this is the value for Y, and this is value for R, such that the angle here, the measure for this angle, the same as the measure for this angle, but the different is the sign. And I will talk about this one of the next part of this section. Okay, so now the question is the most important question for this section: how to find the trigonometric function for any angle. So we have step. First thing we have to know, we have step. You have to apply this step and you will find the angle, the value for the function. First things, we have to evaluate the trigonometric function at any angle, such that if the angle it's in the first quadrant, like for example, look like that, the angle, or the angle look like that, or the angle like that, that's mean all the trigonometric function here will be positive. All sine, cosine, and tan for any angle here will be positive. For the second quadrant, if the angle starting at like that, and this is called the initial side, and the terminal side in the second quadrant, that's mean the only function will be positive here is the sine function. Only the sine function will be positive. If the angle starting at the initial side in the positive x-axis and finishing in the third quadrant, the only side will be positive here is only the tan function. And the same things for the fourth quadrant, the only positive will be the cosine function. So again, we have to know what is the sign for the function. The sign for the all the function here in the first quadrant is positive. Second quadrant, the sign only positive. Third one is the tan, and the fourth one is the cosine. I put it in the table. Here positive, here negative function. So in the first quadrant, if my angle is in the first quadrant, the positive function will be all of them, the sine, the cosine, and the tan. And the negative will be none. No function will be negative in the first quadrant. For the second quadrant, if my angle stops in the second quadrant, the only positive function is the sine function and the reciprocal for the sine. The 1 over sine is cosecant, would be positive. The sine and the cosecant. The negative function, the rest of the function is the cosine and secant for the cosine, and the tan and the cotan. For the third quadrant, the only positive function in the third quadrant is the tan function and the cotan function. The negative function here, it is the rest of them, it's sine and cosecant, tan, tan is positive, the sine and the cosine, and 1 over cosine is secant. For the fourth quadrant, the only positive is the cosine function, the negative is the sine and tan, and 1 over sine is cosecant and cotan. This is first things, the sign of the functions. Any questions so far? This is the first step, how to find the value for any triangle function. First things, you have to know the sign. So the mean for the sign, in the first quadrant, all the sine, cosine, tan will be positive for any angle. For the second quadrant, if the angle is more than 90, like I said, because here we're starting by 0, 90, 180, and here 270. If the angle is in the second quadrant, so the sign will be positive only. Third quadrant is the tan only positive, and the cosine in the fourth quadrant, the last one. You miss secant with the cosine. The cosine one, sine, tan, cosecant, and cotan. Where I miss? I did not miss them. Cosecant and cotan. Okay, so now this is the first things we have. How you memorize that? By using the first letter A, S, P, C. By using the word all student take calculus. So the first letter here, A, it's all. Student, the second letter is S. Sign, take, the third letter is the third quadrant. Calculus, the last quadrant. Just to memorize the table. Quadrant 4 has, does quadrant 4 have positive secant? Such that the cosine, yes. So the cosine is positive, so 1 over cosine is positive. So secant is positive. Thank you, Miles. I think this is what she mean, Taylor too. Thank you, Taylor. Yes, so the fourth quadrant is the cosine and 1 over cosine is secant. Thank you. Any questions so far for this table? This is the sign for trigonometric functions. Now let's go to second part. This is the first part here. It's called A. What's your question, Amber? Can you turn on the mic? Y is positive and negative. Okay, good. Y is positive and negative. Okay. So look, I said before, if we go back here, any triangle, I can place it in the standard position in the XY plane. Okay. So if this side from O to Q, we put it in the positive x-axis, okay, it's positive. And this side from B to Q, we put it in this side, the Y, such that the Y is positive. And R is always positive. That's mean in the first quadrant, look, the theta in the first quadrant is equal, the sign of theta is Y over R. R is always positive, and Y in the first quadrant is positive. Y is positive. Why? Because the value for Y it's in the Y, the positive Y axis. So the sign of the first quadrant, if we put the angle in the first quadrant, the Y will be positive, and the R is always positive, so the sign is positive. For the cosine function is x over R. X in the first quadrant is positive, and R is always positive, so the cosine is positive. The tan, same things. The Y is positive, the X is positive, so the tan is positive for the first quadrant. If my angle it's in the second quadrant, for example, it's like that here, and my angle like that, Q. So here the point is finished at this point, B, X, and Y. And they give me something like that. So from starting in the starting for the measuring the angle, we use the initial term. The initial side is in the positive x-axis, so the initial is positive. No, I mean like to measure the angle, like the green one, we open it from the initial x-axis to this point, the B. The B here in the second quadrant, the B, it's containing from X and Y. The X here is negative in the second quadrant, and the Y is positive. That means the sine of theta is Y over R. That means Y is negative, it is positive in the second quadrant, and R is positive, so the sine is positive, negative. The sine, the sine is positive, sorry, because the Y is positive for second quadrant. By using this point, the Y is positive and R is always positive, so the sine is positive. The cosine it's X over R. X in the second quadrant is negative and R is always positive, so the cosine is negative. The tan, the same things. Y is positive, X is negative, so the tan is negative. So that's why in the second quadrant, the tan is negative, cosine is negative, but the sign is positive. Same things for the fourth quadrant and third quadrant. Why I draw the green? Because if my angle it's in the second quadrant, is not in the first quadrant. It's opening from the standard position in the positive x-axis, and we end it in this point. The angle, it's in the second quadrant. Look, the angle. It's finished in the second quadrant. That means the sign is positive here only. If my angle, it's in the third quadrant, that means we're starting from this point until this point. Here, the point B is x and y. The x is negative and the y is negative. That means the sign will be negative. Cosine will be negative. The tan is negative over negative, it will be positive. That's why the tan in the third quadrant is positive. But if my angle in the fourth quadrant, open it like that, stop at this point. Here the B, it's x and y. So that's mean x here is positive. Why? Because the value for x is positive. Look in the positive x-axis. The value of y is negative because the y here is negative because look, it's in the negative side for y. That's mean that the cosine here is only positive. Why? Because the cosine is x over r, and x is positive and r is always positive. So the cosine only positive for the second quadrant. Make sense? So until now, you have just to memorize which function is positive. Like you have to know to memorize the table. Memorize these things. All, sine, tan, cosine. All student take calculus. All student take calculus. All of the function here is positive for any angle. In the second quadrant, just the sign is positive. For any angle between here and here, like from here to this quadrant. If I open the angle from here to this quadrant, the tan only positive, and the last one is the cosine. In the okay, where is the right angle? The right angle in the third here. What is it? It's here. The right angle, we will use the triangle this and the for example, if it's the green one, we open it from here to here. We use the right angle, this one, this triangle, and the angle here is the same as the angle from here to here. This is called the reference. We'll talk about this one right now. It makes sense? For the third one, we use the triangle, the right angle, this one. This angle is the same as all the angles. This is called the reference angle. We'll talk about this one right now. For the fourth one, the blue one, what do you mean like goes more than one quadrant? It just goes to one quadrant. We open the angle for one quadrant. From the initial side to one point in the terminal side. So the first things we have to memorize this table. All students take calculus. All the functions are positive. And for the second quadrant, sine, tan, cosine. Now we have to know what's the standard position, the reference mode. Second part to find the angle is called, this is B, reference angle. what is the meaning of reference angle? So it has a definition. The reference angle, it's defined by theta has bar, theta bar. So associated, this theta bar is associated with the angle theta, the origin theta, is the acute angle defined by is the acute angle formed by the terminal side of theta. And the x axis. So second part of how to find the angle, we use the reference angle. It's called theta bar. I mean for that, suppose I have a graph look like that. So now I will answer a Taylor question and Amber questions. More explanation here. So for example, start from this side, from the initial side. Always my initial side is always the positive x-axis and the original is 0. If my angle look like that, starting from positive x-axis and stop at this side. So my angle theta. So the reference angle as the definition, it is the acute angle between the terminal side and the closest x-axis. So this is my terminal side, okay? This is my terminal side. So the closest x-axis is this. So this one from here to here, it is my reference angle. Okay, so the reference angle, it is the closest angle between the terminal side and the positive x-axis. So this is my reference angle, the red one. This is called the reference angle. If my angle look like that in this position, in this quadrant, so what's my reference angle? Again, my reference angle, it is between the terminal side, this is my terminal side, and the closest x-axis. So the closest x-axis is this. So this is my reference angle. Okay. Third one, if my angle, it is in the third quadrant, opening like that. So what is the reference angle? It is between the terminal side, this is my terminal side, and the closest x-axis. So to be like this. This is my terminal, my reference angle. For the fourth one, suppose my angle in this side, in the fourth quadrant, open from the positive x-axis and ending at the terminal side in the fourth quadrant. So what is my terminal side? It is the closest between the terminal side and the positive x-axis. So it will be like this. Any questions so far to find the reference angle? It is clear how to find the reference angle. So the reference angle and the angle we have, yes, we have 90-degree angle. But I'm talking about the reference angle. Is it clear? I will talk about the right angles later. So this is the first things we have. This is the reference angle. Any question about the reference angle? Yes. Yes, Amber. Okay. So this is if my angle in the first quadrant, the reference angle is the red one between the terminal side and the positive x-axis. If my angle is open, like under the second quadrant, the reference angle will be this one. Same things for the third one and fourth one. So I will give you a rule how to find the reference angle. So if my angle in the first quadrant, so theta is equal, so theta is equal my reference angle in the first quadrant. Now, for the second quadrant, theta reference is reference, theta reference, or theta bar is equal, how to find it, is equal 180 minus the original theta. Or in the radian, it is equal to, it's equal by minus theta. For the third one is equal the theta reference here is equal to theta, the original theta, minus 180. This is mean theta minus pi. For the last one, theta reference is equal 360 minus pi, minus theta, or it's the same as 2 pi minus theta. This is how to find the theta reference. So second things how to find the value for the angle, it is the reference angle. First things we have to know the sign here. This is the sign. And the second things we have to know the reference angle. Any questions so far? How to find the reference angle? So now I will start giving an example how to evaluate the trigonometric function for any angle. After A and B, I can find the trigonometric function for any angle. But before we go in that, I will answer Taylor's question. So she asked me about the angle, which angle she asked me? About the 90-degree. If it's the angle is 0, So the reference angle is 0. If the angle theta is 0, so the reference angle is 0. This is your question, Taylor? If it's the angle it's 90 degree, so theta is equal 90, the reference angle will be 90 degree. Because I can't find the sine, I can't find the cosine, tan for any function for the theta. This is your question? Oh, okay. So for the third quadrant, the triangle will be look like that here. This one. If it's the angle from here to here, be this one. For the fourth quadrant, it's my angle from here to this one, be using this one, by using the reference point. This is my right angle. I will use it. This is my right angle, and this is my right angle here, and the green one here, this one. Why? Actually, I'm using the reference angle. The reference angle, talking about these things. If my angle is between 0 and 90 degree, the reference angle will be the same angle. If my angle is from 0 to the second quadrant, the reference angle will be 180 minus the theta, or be this things. This is my reference angle. What is the mean of this is my reference angle? Actually, I make like a right triangle, and this is my right triangle. For the third one, the same things. This is my reference angle. Actually, I make the right angle in this side. For the fourth one, the same things. Actually, I make this my right angle here. For the first one, my right angle will be the same things. So by using the first, by using A, this is A, and by using B, reference angle, we'll go over right now the example. We can find, evaluate the trigonometric for any function. So how can we find it? First things, to evaluate trigonometric function, for any angle, first things, this is very important. We find the reference angle. Theta bar with for the associated angle theta, for theta. Second things, we determine the sign for the function. Third one, we evaluate the triangle function. We get the answer. Number one, it is from part B of this class. Number two, determine the sign, is from part A in this class. Number three, we found the value or the answer. Number A, it's this. All students take calculus. We have to check where is my terminal side for the angle. Number B, this is the reference angle. By using these rules. This one, and this one, and this one. This is the rules. You have to memorize these rules. Now, we can find the answer. Okay, example. Find sine 240 degree. Who will give me the answer and how we start thinking for this one? So first things, we find the reference angle of the theta. Find the reference angle theta bar for theta. So 240, the angle 240, if we look into the angles, this is 0, this is 90, here is 180, here 270, and here is 360. So actually 240, the angle, it's in this side. Starting by that, stopping in the third quadrant. Again, this is 0, this is 90, this is 180, and here again 360. So the 240, the angle 240, it's ending in the third quadrant. What does that mean? What is the reference angle for the third quadrant? It is 60. How you think for that, Miles? That's true. How you think about that? By using this rules. We're going back here. The angle in the third quadrant, using this rule. So the reference will be from this terminal side to the x-axis, negative x-axis. That means using this rule, theta reference is equal theta minus 180. Okay, going back to the example. So the reference angle, it is between this side and this side. This is the reference angle. This is the reference angle. So again, the reference angle is equal, by using the rules, the angle minus 180 degree. So this equal 240 minus 180, and this give me 60 degree. This is the reference angle. And again, this is the reference angle in the graph. So the value for the reference angle and the angle, the original angle, are the same, but the difference, it's the sign for the function. The sign for the function is the difference. So actually, the angle theta 240 and the angle theta bar is, I can say, are reference to each other, like they are exactly to each other, I can't say it exactly, but it's exactly for the triangle functions, but the difference is the sign for the triangle function. The difference is the positive and negative for the sine and cosine and tan on all of these functions. It is clear so far? Now, how to find the sine? Now the question is asking about the sine for 240. So the sine for the angle 240 is equal. First things we have to know the sine in the third quadrant is positive or negative. The sine in the third quadrant is positive or negative by using this. In the third quadrant, the tan only positive. That's mean the sine is negative in this quadrant. Go back to the question. So that's mean the sine is negative. This is the first step we put. So sine 240 equal negative sine the reference angle. What is the reference angle? It's 60. And this is equal minus sine 60. What is the sine of 60 from the table? Go back to the table now. That's why I told you have to memorize the table. Going back to the table, what's sine of 60? Square root of 3 over 2, exactly. So the answer is minus square root of 3 over 2. And that's it. This is the answer. We are done. Any question? So again, we have to find the reference, then the sign for the function, and third things, the answer. You need another example? Another example or not? Yes, another example. So my question is, find the cosine, example 2. Find the cosine of the angle 150. So again, we draw the graph. What is the angle 150? I know this is the 0, this is 90, this is 180, and here 270, and here again 360. So the angle 150, it is look like here. From here to here. This is the angle 150. So it's in the second quadrant. Perfect. Again, what's the reference angle? Step by step. First things, by using the step first one, what is the reference angle? It is positive 30, not negative. So the reference angle, by using the rule, it is 180 minus theta. This equal 180 minus theta is 150. And the answer is 30, positive. Now, the question is about cosine. This is the first step. Second step, cosine of 150. So I know the cosine, it's in the second quadrant, is negative or positive? It is negative. Yes, it is negative. So the cosine in the second quadrant is negative. Cosine, the reference point. What is the reference angle? It is 30. So the cosine 150 is the same as exactly minus cosine 30. Now, what's the cosine 30 from the table? Go back to the table. What is cosine 30? Square root of 3 over 2. Yes, square root of 3 over 2. And this is the final answer. And again, by using a step, this is the first step, second step, third step, the answer. Is it clear? That's why I'm talking about the reference and the sign. You have to check the sign, go back to the sign of the triangle function, find the reference. You have to know how to find the reference, then you evaluate the value. I give you another example, but this time will be like a little bit harder by using some idea from section 6.2. The question is, find the cosine for the angle 495. How can I think for these things? This is the example. Find the value for cosine 495. Yes, we're using the coterminal, exactly. So my angle here is best to be between 0 and 360, is best. So first things, we have to find the coterminal for this angle by using the idea we used last time for the example. Yes, we have to subtract it by 360 first, exactly. So first things, by using the coterminal, angle, like I said last time, we adding 360, keeping adding 360, or we subtract by 360. But here the angle I needed between 0 and 360, and the angle is more than 360. My angle 495 is more than 360, so I have to subtract it. So 495 minus 360. What's the answer? Is 135. So this angle 135 is coterminal for the angle 495. This is the first step. So we're adding one more step by finding the coterminal. Second step, we have to graph to know in which terminal the angle. So 135, it's look like in the second quadrant. Why? Because I know this is 0 again, 90, 180, 270, 360. So 135 in the second quadrant. So what's the reference for the second quadrant? It's 45 exactly. So the reference is like, again, 180. The reference angle, it's this here. This is the reference angle. This is theta bar. And this theta bar and the theta actually are similar to each other for the triangle function, but the difference, again, it's the sign. The sign, I mean, like positive or negative. So again, the theta reference is equal 180 minus 135. And the answer is 45. Third step, we have to find the sine for the answer, the cosine, I mean. The cosine of 495, this is equal exactly the cosine for 135, and this exactly equal, again, what's the sign for the cosine? Is it positive or negative for the second quadrant? It is negative. In the second quadrant, the cosine is negative. So minus cosine 45. What is the answer? From the table, 1 over square root of 2. Yes. So again, first step, second step, third step, fourth one. Just we add one more step by using the finding the coterminal. It is 2 over 2, not 1 over 2. It is 2 over 2, not 1. What do you mean for that? It is 2 over 2. Yes, it is the similar. Look, 1 over square root of 2 is the same as square root of 2 over 2. Why? Because actually we multiply both sides by square root of 2, and square root of 2 times 1 is the square root of 2 over, let me write it here, I'll explain it more. So 1 over square root of 2 is the same as square root of 2 over 2. How we found it? Such that 1 over square root of 2, we multiply both sides by square root of 2, like we actually multiply by 1. And this is giving me the square root of 2 over square root of 2 times square root of 2. And this is equal square root of 2 over 2. So the same answer, yeah. Yes, it will be the same answer, exactly. Will not be wrong. Okay, so now let me give you another example. Yes, we can find an angle. It is possible to find the answer with angle not between 0 and 360. Yes, we can find the answer because this angle it's 495, so we can find the answer. What does that mean? This means actually the angle 495, this is the graph, mean we turn around the xy position and we turn again. So stop at this point. That's mean the angle 495. And this is exactly coterminal for the angle 135. Okay? This is what the mean of the angle 495. Okay, another example. Find the secant for the angle minus pi over 4. How can I find the secant for this angle? How we can find the secant? Okay, so again, the secant is 1 over secant function is the same as 1 over cosine function. So the angle pi over 4 minus mean we rotation around the xy plane in the clockwise like that by angle pi over 4, and we'll stop here. So we're starting from this point and we're ending in this point. This is the mean of minus pi over 4. The minus because we rotated clockwise, not counterclockwise, clockwise. So now the question is, find the secant of minus pi over 4. So like before, we're using the step. First things, we have to find the reference angle. What is the reference angle for this angle? I mean, for the reference angle, it is the shortest between the angle and the xy and the x-axis. The shortest angle between the terminal side and the x-axis. In the graph, it's look like the red color. What is it? What is the reference angle here? It is pi over 4. No, it's always, the reference angle is always positive. You have to know the reference angle is always positive. So the reference angle is pi over 4. The reference angle is always positive. So the angle is pi over 4. This is the first step. Second step, we have to evaluate. You have to know the sign. It's in the which quadrant. Because the secant is 1 over cosine, so the cosine in the fourth quadrant is positive. So the secant will be positive too. So the secant of theta is equal 1 over cosine theta, but here we'll not use the theta. I will use the same angle. It's minus pi over 4 is the same as the secant be positive of the reference angle, pi over 4. Here is positive. Here, because the angle it's in negative, it's we're moving here counterclockwise. Because the angle here, no, we don't have to. Here, in this case, we will add 360. In this case, if the angle is clockwise, we add 2 pi. Because the angle clockwise, we add. Instead of we subtract, so we will add. So that's mean 2 pi plus negative pi over 4. But here we don't have to add or subtract because we look into the graph. Is the easiest way when we see the angle is negative, the easiest way we look into the graph and we find the reference angle from the graph. We said, what is the closest angle between the terminal side and the positive and the x-axis? We look into the graph, we ask ourselves, what is the angle, especially when the angle is negative. So when the angle is negative, it's better to look to the graph because we don't want to get confused to find the reference angle. So the first things we look into the graph and ask ourselves, what's the closest angle between the terminal side and the x-axis? And we know the reference angle is always positive. So continuing to solve this question is positive 1 over cosine of pi over 4. What is the cosine of pi over 4? What's the cosine? It's 1 over square root of 2. So the answer is square root of 2. It is clear for all? Yeah. Yes, we can convert the radian to angle, and we use the same things. It is possible. Taylor, she asked, starting from how to find pi over 4 in the graph. Okay, so how we started? Okay, so in our example here, okay, my question is find the secant for the angle minus pi over 4. Minus pi over 4 means I starting in the opposite direction. I starting clockwise. So I have to know my initial side is always the positive x-axis. So here minus pi over 4, it's mean clockwise. So I have to move clockwise. And I know the value here, it's minus pi over 2. This is the maximum here. The value for this negative y-axis is minus pi over 2. So the minus pi over 4 will be between the 0, between this one and this line and this line. This is the first thing. Now, how to find the reference angle? The reference angle, like I said before, is always positive, first things. Second things is between the terminal side. This is the terminal side. The closest between terminal side and the x-axis. So this is my x-axis, and this is my terminal side. So the angle between here and here, it is pi over 4. It's not the negative. The value is pi over 4. So the reference angle will be pi over 4. Now you apply the same things like before. The secant of minus pi over 4, because in the fourth quadrant, so the secant is the same like the cosine. The cosine in the fourth quadrant is positive. So the same things for the secant. Secant will be positive. So positive secant pi over 4. And this is equal positive 1 over cosine pi over 4. Because we know the secant is the same as the cosine, but the reciprocal for the cosine. 1 over the cosine pi over 4. Now we know the value for the cosine pi over 4 from the table. The cosine pi over 4 from the table is 1 over square root of 2. So this one equal 1 over 1 square root of 2, and by using the first chapter, this is equal the square root of 2. Is it clear, Taylor and Miles? Is 2 over radical 2 equal to radical 2? Is 2 over radical 2 equal to radical 2? No, it's not. But because here 1 over 1 over square root of 2 by using the first chapter is equal 1 times we do the reciprocal for the denominator is equal square root of 2 over 1. And this is equal square root of 2 from the first chapter in the book. The first table has the 4 value for secant, but the secant table says radical 2. I can't understand your question, Miles. Can you turn on the mic and ask your question, please?
Yeah, so the first table you gave us for special triangles,
Yes,
the value for
45.
this 45 secant is different than the one you showed us this morning, because it says
But
2
the
over
same,
radical 2 for the value.
it's 2 over the radical 2 for the value, right?
Right, and
But
then
this is the
today's
same.
says radical 2.
Hold on 1 second. It is, okay. So if I multiply both sides by the radical 2, what I have 2 radical 2 over 2. And 2 with 2 cancellation, so I get radical 2. This is the
Oh,
same,
okay.
yes.
Okay, so okay. All right, thank you.
Okay, you're welcome. Who have another question? Rashid, can you show us how to solve if we were to convert pi over 4 to 45 degree? Yes, I can show you. So pi over 4 is the same if when a degree changes to the degree, we have to multiply by what? By 180 over pi. So the pi with the pi is cancelled. So I get 180 over 4. And 180 over 4 is 45. Is it clear, Rashid? This is the convert. We have another question. Yes, you can use it by degree if you want to solve it by degree. Yes, you can. Anyone has a question for this question? For this example, I mean? Yes, you can use it by degree, the same step like this one. I want to show you how to use the degree by using minus 45. Okay. Okay, so the same things. So my angle, oh, it's 1140. Okay, give me just 2 minutes until I finish it. So again, pi over 4 is 45 degree. Okay. So again, here the question asks about the secant for minus 45 degree. So this is the same as, again, we graph it like that. Here minus 45 degree. So again, what is the reference angle? It is between the terminal side and the positive, or with the terminal side, this is the terminal side. And the x-axis, this is the x-axis. And this is the closest one. It's 45 positive. And so the secant for minus 45 degree is the same as 1 over cosine. Hold on, before these things. The secant in the fourth quadrant is positive. And again, the secant will be also, it's equal secant for the reference angle. What is the reference angle here? It's 45, positive. And going back to the table, this is 1 over cosine 45. And this is equal 1 over square root of square root 2. And again, square root of 2. Okay, the class is finished, is over, so I will stop recording the class.